I am Andrea, Product Strategist at Ocean Protocol, and I'm here today with three brilliant colleagues who will be supporting during the workshop. So thanks everyone for joining. I'd like to welcome Trent, co-founder of Ocean. And with us, we also have JP and Jaime, who are also at Ocean Protocol, and they're playing a huge role in shaping the future of ETH Predict. Without further ado, we're gonna give a quick walkthrough of the ETH Predict challenge, the way that it works with Jaime, and then we're going to shed some light on what are the possible ways ETH price with JP. So Jaime, I'll just leave the mic to you.
I'm Jaime, and today I'm gonna go through all the details of the competition, so that we are all in sync with what the competition is about and what are the requirements for it. I'm gonna share my screen. Just give me 1 second.
You know, guys, while we wait, I was wondering whether if you would like to know the price of Ethereum in just 55 minutes. That's coming up. So, no?
So that's going to be in real time price prediction.
It's going to be hardcore real-time price prediction for the next 12 hours straight, you know, computed straight. Yeah. I mean,
And we see the screen now. Fantastic.
Okay. Can you guys hear me?
Yes, loud and clear.
Loud and clear.
So let's talk about the competition. The competition is straightforward. What is required in order to first participate and win the competition is to have the best possible prediction of the price of Ethereum between on December 12th, between 1 a.m. UTC and 12 p.m. UTC. So it's a 12-hour period in which you are required to provide the price of every hour and make this as close as possible to the real value of Ether at that time. And the person that gets closer is the winner. Now, closer in terms we will explain later. That is the normalized mean square error. This is just a detail. In general, this is what is necessary. Now, in order for your submission to be considered valid, there are a minimum requirements that had to be fulfilled. Your prediction should be better than just guessing a single value and assuming that this is the value of Ether. Meaning, if the value on December 11 at 11 p.m. was, I don't know, $2,000 per Ether, your prediction should be better than just saying it's 2,000 for the next 12 hours. Also, you will see in the repository that I'm sharing right now examples of different models that can be used to predict the price of Ether, and then we also expect your model to do better than those models because those are very simple models. So let's go through what would be a standard flow for submitting a prediction for the competition. The first thing is that we need to do a setup to have all the tools that are necessary to use the Ocean protocol to make the submission. This can be done in any environment. It could be Windows, Mac, and Linux. The library is working in all these three environments. So the first thing that is necessary to do is to first create a virtual environment so that you can install everything that is necessary to do the submission there. The library that we are going to use as a base for all this is OceanPy, of course. That can be installed with pip using this simple command. You will still need some extra tools like Bundler and the wrapper around Bundler that is PyBundler that can also be installed in the same way. Because Bundler is a Node.js application, then you also need to install the bundle network client. And this is what you see in this line. Now, in Ocean protocol is a protocol that is running a blockchain, right? And allow people to tokenize assets, and this in particular data or algorithms. Because this is happening in the blockchain, then you need to have a wallet. The next step in the flow is just to ensure that you have a wallet and that this is the wallet that is going to be used to submit your predictions to the network. This is done in Python, sorry, in Polygon. There is a reason to choose Polygon. It's cheap in gas, transactions are fast, and everything is easy to use. So you will be setting your private key in an environment, in your local environment, and later, using the library, we are going to transform this in a wallet that will allow you to send the transactions. But this is to be done only once. Once that you do this, you don't need to think anymore about these steps. And then we can move forward. So the first thing that in the submission that should be done is to create an instance of the Ocean protocol locally. So the example is showing that just opening the console and running these two functions will do for creating the wallet and creating an instance. But in order to reduce the friction, so that you don't need to become a specialist about Ocean Pi, we have provide a helper, and this helper is a series of functions that will make it easy during the submission. So here you will find things how to create wallets, how to create data assets, how to even modify different formats for time, etc., etc. So the only thing that you will need to do is to open a Python console, copy this script, and hit enter. Then you will have available all the functionalities that I'm going to talk right now. Are you guys still with me?
Yep,
Okay.
pretty clear.
Yes.
Then once that you have Ocean, the instance of Ocean, then the fun part start. You need data. To make the predictions about the price of Ether, you had several options. You can guess them, you can dream about it, use your psychic power, but most likely the best way to win the competition will be to gather some data, train a model, and ask the model to make predictions about it. So the data that you are going to use can come from everywhere. You can get data from different exchanges. You can download the data from Yahoo Finance, or use any kind of tools that you want, including the Ocean protocol that have available free price feeds that you can use. You will find in the main repository several examples of how to get data, for example, from Binance, or from Binance and other exchanges through CCXT, even from the Ocean protocol itself, and from the graph, for those who are familiar with this. So you can go directly to this. You will find a script that allows you immediately to get that data. Once that the data is obtained, then the next step is to decide what you are going to do with the data, how you are going to use that data to learn how the price of Ether move depending on the day, or what is the current value and what to expect in the future. For this, you will use any machine learning algorithm that you could think of or that you know how to use. But to make the things easy, we are also providing an example of several types of algorithms, starting with simple linear regressions, autoregressive models, neural networks even. And you will find all these also in the main README in the modeling approaches. So here you will see examples of how to do this. And there is even, if you go directly to the folder of examples, you will find a comparison between all these type of models, between linear models, also using random forests, et cetera. That we may go into details of how to do this in a future workshop. But using any of the models that you have there or that you can come up by yourself, looking in the literature, et cetera, you will generate those predictions. So as an example here, these predictions are generated by assuming that the price of Ethereum is a random variable with a mean of 1,300 and a standard deviation of 25. So you will expect that the price will be around 1,300 and it may deviate from that. And in average, you expect that you will not see values higher than 1,375 or lower than 1,225 in this case. This is just an example of a possible way of predicting things. Of course, it's not informative, but will be a valid prediction. But probably it's going to be a bad one. Now, this is the only thing that you need. You just need a list that have 12 values, and each one of these values is the expected value of Ether in a particular time. Now, once that you have these predictions, the next step is how do you make these predictions available for the judges of the competition so that they can verify that indeed your predictions are the best among all the competitors. So the first thing is to pair these values of the prediction of the Ether price with the corresponding date. And what you see in this script that is here for an example is exactly what you will need to do to pair the predictions with the times, right? This is such that the prediction, the final prediction that you will send are actually according to what is expected by the judges. Now, if you have the predictions and you want to test, you can directly make your predictions to be for a day that is earlier than the actual submission, predict the next 12 hours, and calculate what is the expected error. And this script is also telling you how to use the script that we loaded initially to calculate the error that you should expect. Now, when you are sure that the model that you are using is the one that you want to submit, you can do this many times just to be sure that your predictions are correct. Once that you made a decision about the algorithm, you have your predictions ready, then you can create an asset. The asset is basically going to be a document that contains the times and the values that you are submitting as valid predictions. And for this, what we are going to do is the following. We have a list of numbers with the corresponding dates. We can create a CSV file and then put it somewhere so that the judges can download it. But somewhere is a bit vague. And what we want to do is that you can put this document in a decentralized network, right? In a way that you can give access to these predictions only to the judges, right? And this is what Ocean Protocol is allowing you to do. So in this case, you will use a pipe bundler to put the file that you just created in a decentralized network. And this is going to be your asset. And only you know where this asset is. Once that you get the URL for your file in that network, then you can use Ocean Protocol to create an URL asset that is basically going to be matched with two tokens, with an NFT that is describing the asset itself, and with a data token that is the token that you will use to give access to the judges. So the way that this should be understood is now you have an asset that is your predictions, and you can actually sell it. How do you sell it? By matching a token with access to your data. Because this is a prediction, and you still don't want to profit from this, then you are just going to send a data token to the judge. So the judge is going to receive a data token that will allow them to look at your predictions so that they can compare. Now, once that the asset is created, you mint the token to the judges, send to them, and within 1 week after the competition finished, the judges will download the file and will compare the prediction that you made with the actual values on the specific dates. There is also here a script that informs people what the judges are going to do so that you can do this on your own and verify that what had been done internally by judges is the correct comparison. And then basically you have gone through a valid submission. You are participating in the competition, and on top of being able to win the competition and get the big prize, everybody submission that fulfill the requirements will be getting the same time 250 Ocean tokens. All this just for making a valid submission. Do you have a question at this moment?
Thank you, Jaime. So just for everyone, there is a chat box top right. I shared the link to the README in there for those of you that would like to take a look at it. And so you took us through essentially 4 steps, if I'm not mistaken. So basically the setup, which is all the prerequisites and the installation. Then you showed how we can get data. So we have some data on Ocean, but other types of data sets could also be used for any predictions. Then you showcased how to actually make the prediction. So all the different potential AI models that we could use to then see how we could use OceanPy for sharing the prediction in a tamper-proof way with the judges in this case. If I want to install OceanPy, how long does this setup take on average? Is that quick? How is that?
Yeah, this is done in a matter of a couple of minutes. The only thing that you need to do to install OceanPy is to run pip install OceanLib. This is gonna take 30 seconds. That's
all right.
great.
Perfect. Nice, awesome. Let's see if there are any questions from the community before we jump into the live prediction from JP.
Just before, I just want to make a final comment. You see where the Ocean protocol goes with all this. At the beginning, everybody is going to be developing algorithms that are going to be better or worse, etc., to do predictions. Once that you have an algorithm that is statistically better than just random guesses, what Ocean Protocol is providing you is the way to monetize these predictions. Because now you are able to, although it's not shown for the prediction number 2, you can actually not only to put your predictions as an asset, but you can put your algorithm as an asset. And the way that the Ocean Protocol is built guarantee that your algorithm doesn't leak, meaning people don't know what the algorithm is doing, but the data may show that the algorithm actually predicts the price in a correct fashion, meaning that then you will be able to tokenize the predictions that your algorithm is doing by selling those data tokens. And this is the main goal of all this.
So essentially is allowing people to share their algorithms, their prediction algorithms, without disclosing the actual algorithm itself?
That is correct. But at the same time, you could decide that you want to share the algorithm without, and then allow people to use it to make predictions for free, if this is what. But you could also decide, no, I actually gonna charge. If the data that this is producing is very useful to make good decisions when you are trading, and you can actually start selling access to those predictions. So you can monetize your knowledge through the platform.
Fully. Makes sense. Thank you, Jaime.